What if I told you there's a chemical reaction so powerful that it can melt through solid steel in seconds? This is thermite. Known for producing extreme heat, thermite has been used in various fields, including welding, metal cutting, and military applications. But what makes it so powerful? Let's break down the chemistry behind thermite and understand how it works. Thermite is a mixture of aluminum powder and iron oxide, rust, that undergoes a highly exothermic reaction when ignited. This chemical reaction produces extremely high temperatures, exceeding 2,500 degrees Celsius, which is enough to melt iron and other metals. In this reaction, aluminum acts as the reducing agent, removing oxygen from iron oxide and leaving molten iron and aluminum oxide. The intense heat generated by this process makes thermite a valuable tool in applications that require extremely high temperatures. As we said before, thermite is a highly exothermic reaction between aluminum powder and iron oxide, producing extremely high temperatures. This reaction is a redox reaction, meaning that it involves the transfer of electrons. In the thermite reaction, aluminum acts as the reducing agent, meaning it donates electrons to reduce iron oxide into metallic iron. At the same time, aluminum itself is oxidized, meaning it loses electrons and forms aluminum oxide. Here's the reaction. The driving force behind this reaction lies in aluminum's high reactivity and strong affinity for oxygen. Due to its electropositive nature, aluminum has a much stronger attraction to oxygen than iron does. When aluminum and iron oxide are heated to high temperatures, aluminum pulls the oxygen atoms away from the iron in iron oxide, reducing the iron to its metallic form while forming aluminum oxide. Breaking the strong iron-oxygen bonds in 3 requires energy, but this energy is more than compensated for when the new aluminum-oxygen bonds are formed in aluminum oxide, releasing even more energy. This results in a net exothermic reaction, meaning it releases a significant amount of heat. The heat generated from this process is substantial, producing temperatures great enough to melt iron. This heat causes the newly formed metallic iron to become molten, creating liquid iron droplets. These droplets can reach temperatures hot enough to melt steel. The intense heat produced by the reaction is the reason why thermite can generate temperatures hot enough to melt iron and other metals. Thermite is unique because it contains its own oxidizer, usually iron oxide, allowing it to burn in environments where ordinary fires cannot, such as underwater or in oxygen-deprived settings. This solid-state reaction makes it highly effective in specialized industrial and military applications. It is commonly used in railroad welding, where its intense heat fuses steel tracks together, creating strong, seamless joints. In the military, thermite is used in incendiary devices such as grenades to destroy metal components beyond repair, burning through engine blocks and weapon caches. Additionally, thermite is employed to cut through thick metal structures. It is also used in demolition operations to cut or weaken metal components, facilitating the breakdown of structural elements. The thermite reaction is a powerful redox process that generates extremely high temperatures, capable of producing molten iron without requiring atmospheric oxygen. This makes it useful in welding, military applications, and industrial settings. However, due to its intense heat and potential hazards, it must be handled with care. Thermite demonstrates the immense power of chemical energy, showing how a simple mix of aluminum and rust can generate results. As always, thank you for watching. If you have any video ideas, comment them below, and we'll see you in the next video.